Okay, this is to help use the table, a critical value table, in order to estimate the p-value. So we're going to estimate the p-value. We're not going to find the p-value exactly, but we're going to estimate the p-value. So I want to estimate the p-value, so let's find the p-value, estimate the p-value for the following values of the test statistic, t. Sample size n and alternate hypothesis h1. If you use table A3, you may specify that p is between two values. So that's what we're going to do. P is between two values. So here we have for A, we have t equals 2.336, n equals 5, h1 equals this. So our test statistic t is 2.336, and we want to estimate our p-value. So, and we have a one-tail test. So this tells us, right, we have a one-tail, particularly a right tail test. So coming over here to the table, we can use the table to determine, okay, our degrees of freedom, since our n is 5, our degrees of freedom is 4. So coming over to our table, we can then say, okay, our degrees of freedom is 4, so we are somewhere in this row. So our t, looking at our t now, our test statistic, we are in between, so we have 2.336. We are in between this number and this number. That's where our t is, which means our p-value, the probability under the curve, right, for this condition is between 0.05 and 0.05 and 0.025. So, right, for A, type this out in Excel. Our p-value is in between 0.05 and 0.025. So right, these two values. Since our t is in between these two values, our p-value is in between these two. Okay, so our p-value is in between these two. So here's an issue. So you might notice I'm setting up this inequality, and hopefully you can determine that there's an issue here. So, and the fact that this number is actually the biggest number and this is the smallest number. So technically we should flip-flop these. So let me cheat a little with Excel. Move that over, move this over. There we go. So this is the right way. And it's a one tail, so I don't have to do anything, right? It's a one tail. A right tail test tells us that it's a one tail. So I don't have to do anything to these. So, but for B, I do have to do something to this. So for B, if I want to find these, this is a two-tail test. I do the same scenario. So my n is 18. So I come over to 18, right? No, oh, wait, 18. Am I supposed to use 18? No, this is degrees of freedom. We don't use n, we use n minus 1. So we're using the degrees of freedom here to establish which one's which. And our t, right, our test statistic is 1.307. So we're looking in between 1.307. These two numbers are in between that. So these are my two values. So so my small one is 0.10. My big one is 0.25. Right? So it's in between, my t is in between these two, which means my p-value is in between these two, kind of. But what did I say? Oh yeah, it's a two-tail test. The two-tail test tells us that we need to do something to these, right? Since we have two tails and the table only gives us one of those tails, we have this same amount of area in this tail as we do this other tail, which would be on this side. So I need to multiply by 2 on both of these. So instead of writing just that, I'm going to equal 2 times this. I'm going to cheat using Excel. Equals 2 times that to get. All right, so because it's a two-tail, we had to multiply by 2 to get this p-value. All right, so for C, right, now we have a left tail, but it's only one tail, so this is the easy case, kind of. So the easy case in the sense that I just come down, oops, I come down to here, and I say my n is 51, so that means, right, I use a degrees of freedom is 50. There we go. It's nice that they gave us 51. We get a nice degrees of freedom, which we can use the table on. So now I'm looking for my t in between here, but my t is negative. So what we can do is we can just ignore the negative because all we have is the positive version. So we're just going to take the positive version and say, okay, my t is between, my positive t version is between these two. So, which means my p-value is between these two values. So my p-value, right, the lower one is this 0.025, and my upper one is 0.005. It's my larger value, right? Always backwards. So, and those are my p-values. It's one tail, so I do absolutely nothing. Don't need to multiply those by 2. So now going to D, right? Same scenario, but here we go. It's 2 tail again. So we're going to have to multiply by 2. Negative t. So we got a degrees of freedom of 2 because our n is 3. Our n is 3, so our degrees of freedom is 2. So now we're looking for our t value, and all right, it's negative, even though it's negative over here, and we're going to go and switch it to positive version. So we're going to take the absolute value of it. So we're in between these two values, which means our p value is kind of in between those two. Not really, because it's a 2 tail. So there's my 2 numbers, right, in order from smallest to largest. But there's a problem because it's 2 tails, so I need to multiply by 2. So let me use Excel. Equals 2 times this equals 2 times this. And there we go. So enjoy.